Now we are going to discuss about resistors in series and parallel. So in this question, we are going to discuss about the equivalent resistance of the resistors are connected in series and parallel. So when two or more resistors are connected end to end, they are said to be in series. The resistor could be simple resistor or electrical bulb or heating element or other devices. The three resistors, we consider three resistors R1, R2 and R3 connected in series. The amount of charge passing through the resistor R1 must also pass through the resistor R2 and R3. The amount of charge passing through the resistors are same. Since the charges cannot accumulate anywhere in the circuit, so this is one of the electrical circuit diagram for the resistors connected in series. We consider three resistor R1, R2, R3. Here it is connected end to end. End to end. The end of the R1 is connected to the starting point of the R2. The end of the R2 is connected to the starting point of the R3. Like this it is connected in end to end, means here the resistors connected in series. The R1, R2, R3 is connected in series. Here it is also connected to the potential difference V. Here the I current is passing through the resistor. The I current is passing through the resistor R1, R2, R3 is the same. When it is crossing through the R1, there is experience of potential difference is V1. When it is crossing through the R2, there is experience of potential difference V2. When it is crossing through the R3, the potential difference is V3, because the resistance are different. So there is experience of potential difference also different. Here we can give the simplified electrical circuit of the resistors connected in series. Okay, when the resistors connected in series means here that resistance is called equivalent resistance of the resistor. So that is not a letter RS. So this diagram is also simplified into this. So this is one of the image of the electrical circuit with the resistors connected in series. Okay, battery and R1, R2, R3, it has a resistance are different. Here it is also connected in the circuit. Okay students, now due to the reason the current I pass through all the three resistors is same, according to the Ohm's law we know that the voltage V is directly proportional to the I. If the same current pass through the different resistance of the resistor, the potential difference across each resistor must be different. Okay, so here that resistance of the resistor are different, the current is the same, so there is experience a potential difference are different according to the Ohm's law. We know that V is directly proportional to the I, so we can write same current is passing through the different resistors, so there is experience of potential difference is also different. So we can write V1, V2, V3 be the potential difference across each of the resistor R1, R2 and R3 respectively. Then we can write V1 is equal to IR1 from Ohm's law, V2 is equal to IR2 and V3 is equal to IR3. But the total voltage V is equal to sum of the voltage across through the each resistor. So we can calculate V is equal to V1 plus V2 plus V3. In next step we can write V is equal to, what is the meaning for V1? V1 means IR1, V2 means IR2, V3 means IR3 from Ohm's law. So it is substituted in this equation, means we can write V is equal to IR1 plus IR2 plus IR3. So V is equal to, in right side all the values it has a same I. So we can take the I on outside, I into R1 plus R2 plus R3. Okay, so from this we can write what is the values of the V. V is equal to I into RS. What is the values of the RS? RS means that is a equivalent resistance. It can be written as R1 plus R2 plus R3. When the resistors connected in series, the equivalent resistance RS is equal to R1 plus R2 plus R3. So from the equation we give the explanation for this. When several resistors are connected in series, the total or equivalent resistance is the sum of the resistance of individual resistor. Okay students, based on this we are going to discuss about one example sum. Calculate the equivalent resistance for the circuit which is connected to 24 volt battery, and also find the potential difference across the 4 ohm and 6 ohm resistors in the circuit. Okay students, you can notice a 24 volt, that is a given data. Voltage V is equal to 24 volt, R1 is 4 ohm, R2 is 6 ohm. It is connected in series because it is connected in end to end, so it is connected in series like this. Okay, continuously it is connected means here that is the resistors connected in series. You need to note that. So for the given data, you can note this: R1 is equal to 4 ohm, R2 is equal to 6 ohm. When it is connected in series, we can write the effective resistance RS is equal to 4 ohm plus 6 ohm is equal to 10 ohm. The current I in the circuit is calculated by using the formula of V divided by R. So we know the equivalent resistance, so we can write the formula I is equal to V divided by R equivalent. So 24 divided by 10 is equal to 2.4 amp. So we need to calculate the voltage across through each resistor. You know the formula from the Ohm's law. We know V is equal to IR. Here V1 is equal to I into R1. So the I values is calculated, that is 2.4 ampere into 4 ohm. It is given the values is 9.6 volt. Then voltage across through the 6 ohm resistor, we can write V2 is equal to I into R1. So we can write that is I is equal to 2.4. V2 is equal to I into R2. This is a value is R2. Student, you change that. There is mistake in notebook. That is R2. V2 is equal to I into R2. That is equal to 2.4 amp into 6 ohm. It is equal to 14.4 volt. Okay students.